Hello everyone, welcome to today's class. This is teacher Simon taking you through mathematics paper 5 and this is 9709/51 for May June 2025. This is probability and statistics 1 and this is part 1 for questions 1, 2, 3. Question 1 is coming from normal distribution. They are saying the masses of the bags of rice made by a company are normally distributed with mean mu and standard deviation 0.14. Then the probability that the mass of a randomly chosen bag of rice is less than 1.48 is 0.22. Find the value of mu. Okay, now this is our probability of, let's say the random variable here is x, which represents the what? The masses of the bags of rice. So if it is less than 1.48, it is given as 0.22. And now I need to standardize this. So where there is x, I'm going to put z less than, I don't know the z value here, so I'll put, let's say, z1, then this one is equal to 0.22. Now we need to know the z value that gives us this probability. So the first thing you do, because z value can be a negative or it can be a positive, okay? So the first thing to do is to sketch this bell-shaped curve, and you sketch two of them such that you can be in position to judge. Okay, I can put my z1 on the right, I can put it on the left of the mean. If it is on the left, it is a negative. Remember, mean of a normal distribution is what? Of a standardized one is 0. Now we are looking at less than, so you look at this side here, less than this or less than this one here. Now you ask yourself, which of these two can give 0.2? We know that half of this one, half of the graph is 0.5, not so. So that means if we are taking this z1 to be here, the positive one, that means we have a 0.5 here, then plus something here. So meaning the answer here is going to be greater than 0.5. So we cannot take this one here, okay, because this region is greater than 0.5. So that means it will be greater than 0.22. So 0.22 can be here. You see that? So that means we shall have z1 here, which is going to be equal to the phi inverse of this 0.22. But then when we go to the list of family, we don't have these values that are below 0.5. okay, since z is just a boundary point, okay, between those two regions with those probabilities, then we can take the one for the greater. Okay, so what we are going to do is to instead subtract this one from a 1. So therefore negative z1 will be equal to the phi inverse of 1 minus the 0.22, and that one is going to give us what? This one is going to give us 0.78. So we instead look for the probability here, which is 0.78 in the body, and then we can get the z1, then we can use that to find out the mean. So when we go to the normal distribution table they give in the list of family, what do we have? So this is the one we have, and you can see for them they give for the less than the z value. Now we are looking for 0.78. 0.78 would be here, 78. So that means I will take this smaller value, which corresponds to these values here. It corresponds to 0.77. okay, now there is something that we need to add onto this value here to get the 0.78 also. So 0.7800 subtract 0.7794. Here we shall get a 6. Okay, the rest will be zeros. Now we go this side and look for a 6, which is here, that we have gotten here. Okay, and then we go up here, we get that 2 there, then we can add it here. So that will be our z. So we have seen 0.7794 and the other side, and it is the one that we are subtracting from 0.7800. So when we subtract, we are getting a 6 here, okay? And this 6, we went this other side to look for it, but then we saw that it was under add 2. So therefore, negative z1 is equal to 0.772. And z1 is therefore going to be negative 0.772. Now we know that z is equal to, when we are standardizing, it is x minus mu. Then we divide by the standard deviation. So this is negative 0.772, which is equal to, our x was 1.48 here. And then we shall subtract mu that we are looking for. Then out of the standard deviation was given as 0.14. So we put here 0.14. Then when we cross multiply, we shall have negative 0.772, then times 0.14. Then this one will be equal to 1.48 minus mu. We are making mu the subject. I can bring it to this side. It becomes a positive, right? So mu then will be equal to the 1.48. Then this one will go this side. And remember, it is a negative, so it will also become a positive. 0.772 times 0.14. Now, what will be our answer to three significant figures? 1.48, then plus 0.772 times 0.14. We get 1.58808. And to three significant figures, I can write that one as 1.59. Three significant figures. As simple as that. Question 2 is coming from combinatorics or permutations and combinations. Part A, find the number of different arrangements of the 8 letters in the word kangaroo in which the 2 A's are together and the 2 O's are not together. So I'm going to take my sample space where the 2 A's are together. So when we are arranging these letters, we can find A's when they are together, when they are not together. You get it? So when O's are together, when they are not together. So I'm taking my sample space when the 2 A's are together. So if the 2 A's are together, then these O's can be together or not. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8. My A's are together. That means they form one group. Okay? They form one group. So this will be 1, then 2, 3, 4, 5, 6, 7. So I'll have 7 factorial. Then we are having two O's in there, and they are repeating. So we shall have out of 2 factorial. This one represents 2 O's. Okay? Then I will also have 2 A's are together. Okay? And I will also have 2 O's together. You get that? So let me just duplicate this one here. I will also put O's together. Now that means this one will give me another group. So that means I have 1, 2, then 3, 4, 5, 6. So we shall have 6 factorial. Okay? Now, I think that is that because we don't have any other repeating letters. I would have multiplied by 2 factorial because we are having 2 A's, okay, here in a group, because we can rearrange them in 2 factorial ways. But again, you will find out that I would divide by 2 factorial because they are in a same straight line, okay? They are arranged in that straight line. The same to this one here. I would say 2 factorial then I divide by 2 because they are in a line and they are repeating. The same thing that I would do here, 2 factorial over 2 factorial. So when we have these identical letters, then we don't put this one here, because it's like we take it as one letter, because what you multiply up here, you are going to divide, and then everything goes away. You see that? So that means when we are getting two A's together and and the two O's are not together, it's a matter of getting this one then minus this. So it will be 7 factorial out of 2 factorial, then minus 6 factorial. So what do we get here? 7 factorial out of 2 factorial, then you subtract 6 factorial. We get 1800. As simple as that. Alternatively, this is what we can have. You choose the method that is simpler for you. I'll have 1, 2, 3, 4, 5, 6, 7, 8. Let's say I have my A's here. Okay. Then I can put an O here. Then the other O can go here, 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 or here. You get it? So how many spaces do we see here where we can put the O? We are seeing spaces are 1, 2, 3, 4, 5, 6. Okay. And out of those 6 spaces, I'm going to take out 2 for the O's. You get it? I'm going to take out 2 for the O's. So meaning I'll have 6 permutation 2. You get it? All right. Then what else? But since these O's that I'm putting here, one is here, maybe another one is here, they are in a line. Do you get that? So since they are in a line, then I'll divide by 2 factorial. So 6 permutation 2 divided by 2 factorial is actually the same as saying 6 combination 2. Okay. Then I will multiply by these other letters. Remember, we have K, there is N, there is G, there is R. Those are 4. Then, and this one group here, they will become 5, right? So if they become 5, then there are 5 factorial ways of arranging them. Remember, we are not going to say times 2 factorial for the arrangement of these A's, because we shall divide it. We shall divide by the 2 factorial because the 2 A's are in a line. So when we get 6 combination 2 then times 5 factorial, do we get the same answer? Let's check. 5 factorial then times, we have 6, then permutation 2, then we divide by 2. 1800, same answer. So that is that. Then part B, a fair 8-sided dice has faces labeled these letters. The dice is rolled repeatedly. If it is rolled repeatedly, then it is either a binomial or a geometric distribution. Okay. Then part B, find the probability that fewer than 6 rows of this dice are required to obtain an A. Now, first of all, we don't know the number of times the experiment is done. So since we don't know the number of times the experiment is done, this is therefore a geometric distribution. This is a geometric distribution because n isn't fixed. Okay, now our P, probability of getting the success, is the probability when we get an A, not so? How many A's do we see? There are 2 out of 8 letters, not so? Which simplifies to a quarter. Then probability of not getting the A will be 6 over 8, which is 3 out of what? 4. Now, they are saying fewer than 6 rolls. Now, in a GP, when you, in a GP, it is like this. You get the success, you stop. When you fail, then you can continue. So P, then Q, you fail, then you go on. You fail, then you go on. Okay, you fail, then you go on. I'll stop here because they said less than 6. So this is 1, 2, 3, 4, 5. That means we have P plus QP plus Q squared P plus Q cubed, then P, then plus Q power 4 P. Those are the ones we are taking. But do you realize that it is this one that has not been taken into account? Yes. So that therefore implies that probability of x less than 6, it is going to be 1, then minus this q to the power of what? 5. Not so. Q to the power of 5. So this is 1 minus, our q is 3 over 4, then to the power of 5. So what do we get here? 1 minus 3 out of 4, then to the power of 5. So that is that, and to 3 significant figures, I'm going to write that as 0.763. 0.763, 3 significant figures. Or, like I said, let me try to shift this one a little bit here. I've said we can have alternatively, you take the one that is simpler for you. Alternatively, probability of x less than 6, we are seeing a p here, then plus qp, then plus q squared p, then plus q cubed p, then plus q power 4 p, Let us substitute these ones. P is a quarter, then this one will be 3 over 4 times a quarter, then plus 3 over 4 squared times a quarter, then plus 3 over 4 power 3 times a quarter, then plus 3 over 4 power 4 times a quarter. So all together, when we put in the calculator, do we get the same answer here? A quarter, then plus, we have 3 over 4 times a quarter, that's a 3 over 16. Then plus, the next one will be 9 over 64. 9 out of 64, because we have 4 squared and then another 4. Okay, so it becomes 4 cubed. Then plus 3 cubed, that is 27. Then we are dividing by 4 power 4. So 4 power 4. Then plus, the other one will be 3 power 4, which is 81. Then out of, it will be 4 power 5. You see, it is the same. This fraction gave us the 763. 0.763, 3 significant figures. So any you want to use, you get the answer. And then part C, they're saying find the probability that the second A is obtained on the 6th roll. So that means if we have 1, 2, 3, 4, 5, 6. So there is an A here. That means in here there is 1 A and 4 failures. You get it? In here. So the first A can be in this position, it can be on the second one, it can be on the third one, it can be on the fourth one, it can be on the fifth one. Okay, but in there we are having the probability of getting that A, which is 0. What? 0.25. And 4 failures. The rest are these ones here, 4 of them. But then this one is going to happen 5 times because it can be here, it can be here, it can be here, it can be here, it can be here. And you're supposed to consider all of those. So I usually consider this like as if it is a binomial. So here it is a binomial. I have 1 success and then 4 failures. So the probability that we are looking for here is going to be, out of those 5 times, we have only 1 success. Leave out the 6th one, okay? I'm considering this. Then in there, I'm having 1 success. The probability of getting the success is 1/4. And then the probability of getting the failures is 3/4. And these ones are appearing 4 times. You see that? Then we shall multiply by now the probability of getting an A, the success here, which is what? 1/4. You see that? Now, in the schemes, you will find this one is a 5, and then there's a 5, let's say times 1/4, then squared, and then times 3/4, then to the power of 4. So what do we get here altogether? 5 times 1/4 squared is 1/16, then times 3/4, and then we can power this one with a 4. So our answer becomes 405 out of 405 out of 4096. And to 3 significant figures, this one becomes 0.0989. 0.0989 to 3 significant figures. That is that. Question 3. Last Sunday, teams of runners took part in a charity event. The time taken in seconds to run 50 meters was recorded. Correct 1 decimal place for each runner. The times recorded for 11 runners from each of the gulls and herons are shown in the table. Now, these values are given in decimals. See that? But here they are saying part A, draw a back-to-back stem and leaf diagram to represent this information with gulls on the left side. Very important. If you put gulls on the right-hand side, then you'll be marked wrong. Now, when we are drawing this stem and leaf diagram, we are not going to put the decimals. The decimals will be reflected in the key. The numbers on the leaf, okay, must align vertically. Those numbers must be in a line vertically, okay? In the stem, they are increasing downwards. In the leaves, they are increasing away from the stem. So they do like that, okay? Now let's draw what we are supposed to have here. So first of all, we have these numbers are going from, we can see 7, 8, and 9. Yes, 7, 8, 9, and 10. So I can have my 7, 8, 9, and 10. Then from there, we can have these lines here. Then after that, we can duplicate this and put it here. And then after that, I can also have another one here. So here we can have this labeled for girls. I don't know whether that is how they pronounce it. Then herons. The good thing, the figures are given in ascending order. So let's begin with herons. So for herons, we don't have any 7s, but we have, no, they are not actually arranged in ascending order. Pardon me here. It is so for girls, but not herons. These ones are not in order. So the first one is 8.1, then there is 8.3, there is 8.5, and there is also 8.17. So 8.1, then 3, then 5, and then 7. Remember, you don't put the decimals, please. They don't appear there. Then after that, we shall now go to, remember, we have taken out this, and that. Let's go to nines. There is 9.2 here, 9.3, 9.5, 9.7, 9.9 are 2. Okay, so I'll put 2, 3, 5, 7, and then 9, 9. These numbers must align vertically, remember. Then after that, we go now to 10. So we are seeing 10.8 here. So I'll put that one there. Then next, let's go to girls. We have 7.9, so I'll put a 9 here. Then for 8s, there is, what do we have? All of these ones. So we have a 2, we have a 3, and then we have 2 6s, and then what else? We have an 8. Then let's go to the 9s. They are here. 9.2, 9.7, 9.8. Then 10s, we have 10.0, then 10.4. Now, suppose one of them had something like 11 point something, and 11 is there, and then it has a value, let's say this side, okay? And this one doesn't have, we don't put anything this side. Because when you put, because we don't see any figure here, and then you put a 0, then it will become 11.0. Or let's say herons had these numbers here, but there was no 9 point anything wasn't there. So that wasn't there for girls. That means here we don't put anything. It just remains like that. You see? So you have to be very, very careful when it comes to that. Okay. And that will be our stem and leaf diagram, but it makes no sense without the key. So I need to put the key here, and actually it has a mark. So the key, I can pick one value on the left, then in the middle, and then on the right. I can take this one here, and I say this is 2/8/1. This one represents 8.2 seconds, because these are times, right? Seconds for which group? Girls, not so? So I say for girls. And then what else do we have? This is 8.1 seconds, 8.1 seconds for herons. Please don't write your scale here like this. 2/8 represents. Then you go 8/1 represents. This one, they can give you the mark if you are like in grade 7, but not here. So our scale, based on how this one is drawn, you pick a number on the left, then in the middle, and then on the right. It doesn't matter where you pick. I can pick here. You see that? There is something I talked about. If one of them has no number there, you see herons has nothing in the 7s. You see? So we left it blank. Don't put anything, like nothing is there. So maybe you can put the 0s. You get everything wrong. So that is our back-to-back stem and leaf diagram. Then part B, find the median and then the interquartile range. for girls. Median is going to be a half of the distribution. How many do we have? How many numbers do we have here? They said there are 11 runners. So if there are 11 runners, then we shall have 11 plus 1. You add 1, and this one will give you the 6th value. And since for girls, these ones were put in what? In ascending order, I can just say this cross with this one with this one. You cross from the extremes, okay? Then what remains in the middle is the answer, which is 8.8. You see that? Now, if they are 11, I'm left with 1. Suppose, based on the formula that I've used here, because you can have very many, why am I adding a 1? So you can see that this is 1, 2, 3, 4, 5, 6th value. So it's an odd number, 11. When I add a 1, it becomes 12. Then I divide by 2. Okay, then I get the 6th, the one which is in the middle here. So that is what we are having there. So it is 8.1. And avoid, when you are crossing here, after that, you do it in a pencil, then after you do it, you rub. But if you cross each and everything here and then you present your work, it looks ugly. Okay, so this one is 8.8 seconds. That is that. Then let's go to the lower quartile. Lower quartile, Q1. I can say a quarter of the 11 plus 1, same thing as I did here. 12 divided by 4, that is 3. So that is the 3rd value. And then the upper quartile, we denote it with a Q3. That would be 3 quarters. 11 plus 1. So 3 times 3, that will be the 9th value. So the 3rd value for girls is 1, 2, 3. That is 8.3. So this is 8.3 seconds. And then the 9th value will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 9.8. 9.8. Now, to get the interquartile range, it is just the difference between the upper quartile and the lower quartile. Q1 minus, Q3 minus Q1. This is 9.8 minus 8.3. And this one gives us 1.5. As simple as that. The next 2 other teams of runners, the Eagles and the Swifts, also took part in the event. The recorded times in seconds for 20 runners from the Eagles and 30 runners from the Swifts are denoted by X and Y respectively. It is given that the summation of X, that is 175, and that the mean of Y is 8.4. Find the mean of all the times taken by all the runners. A mistake which is done here is for someone to find the mean of X, then plus the mean of Y, then they divide by 2. No. When we are finding mean, you get the sums of all the figures, then divide by how many they are. You get that? Now, we know we are given Y, the mean of Y is equal to 8.4. This one is the same as saying add the values of Y, all of them, then we divide by how many they are. And Y represents Swifts, right? Which is 30. 30, then we equate to the mean, which is actually what? 8.4. So when we cross multiply, that means the sum of the Y values is 30, then times 8.4. Now, the mean of all of them is going to be get the sums for the x, then also add the sums for the y, then divide by the total number, n1 plus n2. So summation of x, that is 175, then plus the other one is 30 times 8.4, and then we divide by, this one is 20, then the other one is 30. So what is our answer here? 175 plus 30 times 8.4, and then down we have a 50. So we get 8.54. 8.54. This becomes our answer. Then next they are saying it is given that the summation of x squared is 1823. It is also known that the standard deviation of the times taken by all 50 runners is 1.38 seconds. But define the value of summation of y squared correct to 1 decimal place. Now, we know that standard deviation is root of variance, and variance is the difference between the squared means. Okay, so it is square root of summation of x squared. I must have summation of y squared here, then out of n1 plus n2, then subtract the mean for both of them, for all of them. So we shall have summation of x plus summation of y, then out of the n1 plus n2, and then brackets what? Squared. So the standard deviation is given by 1.38, and then we shall have the square root of this one is 1823 plus this one that we are looking for, out of course this is 50, and then minus, do you see that this one here is what is here? So I can have, since it is a terminating decimal, I just put it here, squared. Then we can square both sides. When we square both sides, the square root will go, not so? So we shall have 1.38 squared, then shall be equal to 1823 plus the summation of y squared out of 50, then minus 8.54 squared. Take this one this side, we shall have 1.38 squared, then plus 8.54 squared, then this one will give us 1823, then plus the summation of y squared out of what? 50. Then you can cross multiply, then after that you subtract the what? The 123. That means summation of y squared is going to be equal to 50, then times 1.38 squared plus 8.54 squared, and then minus 1823. So then what becomes our answer here? All right, my summation of y squared being equal to 50 into 1.38 squared plus 8.54 squared, I'll close the brackets, then minus 1823. I get my answer as 1918.8. 1918.8. This is an exact figure, so you don't need to write it to three significant what? Figures. All right. Okay, so they even said we give our answer correct 1 decimal place, you see, and it has come out as that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.